Uh, fuck. Yeah. Okay. What's up, fellas? My name is Arson, and I'm the host of this series, Speedrunning Math. Today is a bit of a special episode because I have a beer with me. So when I'm on the BIS, it's a bit different. But it's only one beer, but I am pretty sensitive to beer. So yeah, let's get right into the message of the day. So the message of the day is one that I think there might be a lot of sayings like this, but to put it bluntly, it's be your best company, We spend most of our lives, not most of our lives, literally all of our life, mm, thinking and having an inner dialogue. So be your best company. Make sure you love yourself. Make sure you look after yourself and all that good stuff. Shouldn't be said, but not enough people do it properly enough. Anyways, let's get straight into math. Um, say like, fuck. The first part of the video is never scripted, by the way, which is why I always like fuck this up. I'm gonna say like 10 seconds in. Okay. And if you didn't see my announcement, I actually fucked up. I was meant to upload this yesterday, but there was an issue with the recording, so I ended up just delaying it to today. And so I've already gone through some of these problems, but I'll go through them again. And I holy shit, I made so many careless mistakes yesterday. It was like pretty painful. So I'm low key glad that I didn't have to upload that video. But if those things happen and nothing is wrong with the video, then I just upload it anyway, because that's like the raw and real kind of like process of learning math, and that's kind of what I want to show to you guys. So we'll go through this. Hopefully it's a bit better. Um, and one thing I did realize is that when it comes to solving problems which require a lot of manual calculations, um, like people don't consciously think about it. Maybe the better mathematicians do, but your likelihood for or your probability for making one careless mistake somewhere along the line is like increased dramatically versus if there were only, let's say, three manual calculations that you had to do. And I realized that I prefer doing manual calculations on paper because it's just hard to write with a mouse. So um, if there are any manual calculations, I will probably just do it on paper and not show you guys. Sorry about that, but I will invest in a Wacom maybe for season 2. But for now, you know, part of why I'm doing this learning math stuff is because it's free. Um, and I don't want to end up spending too much. And I don't have a big viewer base, so this is really for myself. Yeah.
Higher degree, we've done this in the past. We
Intro to long division of polynomials. If you didn't know what long division is, it's when you let me pull up the let me see here. Open the scratchpad. This is my stuff from yesterday. Long division is when you write the symbol like this. For example, 2 divided by 8.
get to
It's very straightforward. Um,
maintenance you knew how to do and do did plus 3.
Also, I'm still a bit sick. Yeah. Ugh. I don't like this beer. So this is read as x squared plus 3x plus 6. This is a quadratic divided by a polynomial. Monomial, I guess. Um, and all you do here is you divide this by this, and then whatever that value was, you multiply it back to this whole term. You put it down here, and then you subtract it to the thing above, and then you slowly get rid of the equation, and you end up with a remainder if there is any remainder at the end. And if there's no remainder, it'll be obvious.
And you'll that squared x 1 over x 2 times. 2 times x is
Okay.
2.
Let's go and do this. So this is fine, I think. I will do them on my paper. I'll stick to the paper. Okay. So the divisor, the dividend is x squared. Let me double check. I actually want to see dividend divisor. The dividend is what is being divided, and the divisor is what it is being divided by. So divisor is the one at the bottom, essentially. Okay. So divisor x minus 3. X squared minus 3x minus cancel 3x minus 9 x plus 3x minus 9, no remainder. So it's just x plus 3. X squared minus 7x plus 12 x minus 3 x x minus 3x minus 4x plus 12 x minus 4 minus 4x plus yeah, plus 12, no remainder. Whew, fuck, it is hot. Christ, I have the door open already. X squared plus 6x plus 9. Oh my god, what am I doing? X plus 3. X squared plus 3x minus 3x plus 9 x 3 x plus 3 x plus 3 x squared plus 3x minus 4x minus 6 x minus 4. No, I think I did something wrong. There should not be a what? Yeah, I did something wrong. Plus x minus 6. My god, that is so fucking hot. Minus 2x minus 6. What? Is that wrong again? No, that's right, Minus 2 minus 2x minus 6, and then the remainder x minus 2. Missing x term.
Fun than we expected. So let's keep going. This polynomial division business is a little bit more fun than we expected. So let's keep going. So let's say that, I guess, again, someone walks up to you in the street and says, what is x squared plus 1 divided by x plus 2? So pause this video and have a go at that.
Okay, I will solve it on my paper. X plus 2 on the outside. X squared plus 1 on the inside. X squared 2 plus 2x minus cancels minus 2x plus 1 minus 2 minus 2x minus 4 cancels 6 5 x minus 2 remainder 5, so x minus 2 plus 5 over x plus 2.
And I'll give you, so there's, did I do that? And now, as long as x does not equal that little constraint, if I want to say that this expression is the same as that first expression, for x not equaling 2, the different degrees. So x squared plus 1 has no first degree term. So I'm going to write the 1 here. X to negative 2 get it here because we want to subtract the negative 2x minus, and then this will be remainder.
Okay, let's go. With remainders, so I will just assume there's always a remainder. There's another thing we can do, I'm pretty sure. Fuck, I'm running out of paper, guys. It's not good. Let me just verify this. X minus 2, x minus 3. No, wait. X minus 2, x minus 1. First, outer, inner, last, first, outer, inner, last. Okay, so positive 2 is that. So it can be, no, x minus 2, x minus 1. That will give us that. So really, we can do completing the square method. So we separate the 9, we put it to the side, and then x squared minus 3x. This is our uppercase A, uppercase B. Now, if we do x minus 2, let's set that as one of the binomial factors of our quadratic that we're about to make. We know that uppercase B is supposed to be A plus B, like x plus A, x plus B, the values of A and B should add up to this. So we can express this as x squared minus 3x, and then we add in plus 2. And actually we have to add minus 2 as well, so it's as if it's like an equivalent expression, and plus 9 over here, x minus 2, right? Why did I add 2? Because the factors of 2 that add up to minus 3 is minus 2 and minus 1. So we can actually express this, write it over here, as x minus 1, x minus 2. And if you expand this out, you'll get exactly that. So first, x squared, and then inner, first outer, minus 2x, minus x, and then plus 2. And that will literally equal that. So x minus 1, x minus 2, minus 2 plus 9, that's 7, plus 7, x minus 2, and then we just cancel this like that, and we end up with x minus 1 plus 7 over x minus 2. And I would say this kind of approach is better than long division if you can do it reliably, because there's less steps involved, so the likelihood that you fuck up a manual calculation is actually better. But yeah, that's how I see it. Seven over x minus 2. Fuck off. 7 over x minus 2. Let's try the same thing. We can't try the same thing. Actually, no, we can. So let's just can we? Fuck. Let's try anyways. You know, that's what math is about. Trying new things, seeing if it works. So instead we'll express this as minus 4. Let's do 9. Yeah, 9. So 9 plus 2. Right? Why did we make it 9? Because 9 is a perfect square. This is a difference of squares. And if we break this down, like this thing in brackets, we're gonna get x minus 3, x plus 3, because they're the roots of 9. And technically this is still equivalent expression to this, because we added that plus 2. So what we're gonna do is just we had x squared minus 9. Now instead we're gonna have x plus 3. Oh my God. X plus 3, x minus 3, plus 2 over here, then x plus 3 over here. Cancels. We're left with x minus 3 plus 2 over x plus 3. Okay, plus 2 over x plus 3. X plus 3. Right? Okay, same thing here. We got plus 5. We got x plus 3, so again, x plus 3, x plus something equals, this is a, this is b, this is a plus b. Okay, so a plus b in this case should be equal to 5, so really this can only be 2. Right? X squared Ugh. Fuck, that's so gross. Ugh. I'm dying. Feel like Vol. I can. What is his name? His name is Dumbledore. I feel exactly like this. I feel exactly like this when I drink this beer, and I love beer. You know, fucking drinking the soup. They should have put the Guinness Draught Stout branding on this bowl. Okay. Fuck. What was it doing again? Oh, yeah. X squared plus 5x plus, and we said that one of the monomials is x plus 3. Monomial? Binomial. Binomial is x plus 3. The other one has to be x plus 2. And we know that uppercase C is A times B. Like, the two... You know what I mean? You know what I mean. Fuck. Wait, I need to explain that right. No, I don't. Okay, I'm just gonna do it. I'll explain the next one. 6. Plus 6. And then we'll just put minus 1 on the outside. Because then it's still equal to that. And then this is equivalent to x squared. To be honest, I didn't even need to write this. Fuck. X plus 2, x plus 3. X plus 3. Cancels, cancel. So we're left with minus 1. Then our answer is x plus 2 minus 1 over x plus 3. Okay, same thing here. X squared plus 2. So this is not a perfect square. But if we do this instead, minus 1 plus 3, because minus 1 plus 3 is still 2, then we can actually just do that. Then it's a difference of squares again. So we will end up with x plus 1, x minus 1, plus 3, x minus 1, cancel, cancel. Then we'll be left with x plus 1 plus 3 over x minus 1. Three over x minus 1, x is 1 plus. Cool. Okay, this is where I got butt fucked yesterday, so let's hope
Right
that's
over
not
here.
the case this
You'd have
time.
The form of your answer should either be just a x squared, 3x squared.
Learn how to divide polynomials by linear factors. This tutorial guides you through the process of algebraic long division, focusing on the highest degree terms first. You'll master the art of subtracting polynomials, handling remainders, rewriting expressions in different forms. Okay, he just did long division. It's just long division, I'm pretty sure. Just long division. Okay. Missing term.
Not screenshot from Khan Academy, and I've modified it a little bit so I have a little bit of extra space. We've done stuff like this, but like always, I encourage you to pause this video.
It's gonna be the same thing. It's
work
just long
on this
division, I'm pretty sure.
on your own, and if you were doing
That's long division with the remainder. That's why there's an x minus 5 over there.
This one kind of, you just apply both of these times 3 times. And the reason why you have to constrain that is
Okay.
the whole
And then just
the whole
remember the
reason why we can
constraint.
even divide by x minus 5 is we're assuming that x minus 5 is not equal to 0. And it's generally not equal to 0 as long as x does not equal to positive 5.
Okay. This is where I will stick to my paper, because these equations are a bitch and a half to do, like, on the fucking mouse. Okay, make sure I'm solving the right question. X minus 3 is the divisor. X cubed minus 4x minus 15. Okay. X squared. X cubed minus 3x squared minus 3x squared minus 4x minus 15 x plus 3x squared 3x minus 3 is minus 9x minus cancels, becomes 5x minus 15 x to that minus 5 minus 5 5x minus 5 plus 15, no remainder, x squared plus 3x minus 5, x squared plus 3x minus 5. Ah, fuck! Wait, what? Let's see. Minus 3x squared minus 9, okay, 9x, 4x, 5x minus 5, minus 5, how is it wrong? Wait, what? X squared plus 3x plus 5. Fuck, at the very last step. Okay. Try this one. That beer tastes like shit. I might just throw them away. X, 2x squared, 2x cubed, minus 10x squared, minus, end up with negative 1x squared, plus 25, minus x, minus x squared, and then plus 5x. Minus 5x plus 25, end up with minus 5. Is that minus 5? Yeah. Minus 5x plus 25, and then minus. It's like the same one as last time, but my wrong answer is the right one. God damn it. Okay, take my time. I literally took like 50 minutes to get a 75% in a four question like quiz, because it's just fucking hard as to like not fuck up. Anyways, x minus 5x cubed minus 22x squared minus 17x plus 11. 5x squared, 5x cubed minus 10x squared. Subtract, cancels. Negative 12x squared minus 17x plus 11 x, and that minus 12x minus 12x squared minus 6 plus 60 plus 60x, subtract, cancels. Negative 77x plus 11. Okay, running out of space here. Minus 77. Minus 77x. Minus 77 times 5. Minus 385. Plus 385. Minuses 385 plus 11, 307 minus 374. So our thingy is minus 12x minus 77 plus minus 374 divided by x minus 5. Holy shit. Ah, fucking hell. Fucking hell. Hey, give me a sec, guys. Let me just change quickly. I'm back, fellas. Okay. You know, yeah, while I was away, where's the frickin' script? Bro talk. Bro talk. Oh, fuck, not VS Code. Close. Close. Bro talk. Fuck, what time is it? 34. Dude, I realize like this is not the point of math. The point of math is not to be like, you know, scrutinize every little careless mistake. I think that at the end of the day, it's really just about learning mainly. But also, on the topic of that, I just realized like, okay, I can avoid more careless mistakes if I check as I go. Like, measure once, no, measure twice, cut once kind of thing. So every time I do a manual calculation, I will check that it's right. Okay. So let's try that now. and I will do it on the on the page. So then it shouldn't matter, you know, because I'm checking as I go. Okay, we're gonna do long division here. So x plus 1. I will write it a bit higher so we have space. 3x cubed plus 10x squared plus 7x. Okay, 3x cubed divided by x. That's 3x squared. Yep, I'm happy with that. So that's our first thing. Now here we have to do 3x cubed. 3x squared plus, times 1 is 3x squared. Parenthesis minus. Is that right? So 3x squared, boom. 3x times 1, boom. And minus. These get cancelled out. This becomes minus 3x. 10 minus 3 is 7, so 7x squared. And then that one drops down. So I'm happy with that so far. That was our first manual calculation. Okay, now here. 7x squared divided by x. 7x goes down here. 7x times 1. 7x. Parenthesis minus. Add. This cancels and these cancel, so we stop there. I'm pretty sure. 0. 3x squared plus 7x. Okay, next one. Remember, measure twice, cut once. 2x cubed minus 13x squared plus 9x minus 16. 2x cubed divided by x. 2x squared goes like this. 2x squared times minus 6. That's minus 12x squared. Parenthesis. Again, I'm happy with that. 2x squared, boom. 2x squared times minus 6, minus 12x squared, yep. Okay, now moving on. This becomes positive, these cancel out. So this is bigger, so minus x squared is left, plus 9x minus 16. Okay, minus x squared divided by x. Minus x, okay. Minus x squared times x, minus x squared. Minus x times minus 6, plus 6x. Yes. Is that right? No. Yes. Yeah, that's right. Minus minus plus 6x. Okay. And then go here, parenthesis, minus. Cancels out. 9 minus 6, 3x. Drop down, minus 16. 3x divided by x is plus 3. 3 times x, 3x. 3 times minus 6, minus 18. Parenthesis, minus. These two cancel out. Minus 16 plus 18, because minus minus. So 18 minus 16 is 2. So our answer is 2x squared minus x plus 3 plus 2 over x minus 6. 2x minus 6. Let's just double check that's. And now, like, I shouldn't even be checking if the answer is right now. I should have been doing that as I gone through. You see these lines? Before I write that line, it should be correct. So the value of 2x squared minus x plus 3, they should all be correct because I checked as I went through, which is superior to how I've been doing it. Kind of going back and forth, trying to look, because if you complete all of these manual equations and you try to look, oh, like, does it look right? Well, you can't really tell because you're too far gone. You already have the finished product. So just make sure you develop your answer from the ground up, I guess, is what I'm trying to say. 2x squared minus x plus 3 plus 2 over x minus 6. Because these are not hard problems. These are actually very easy problems. Yeah. So they are not sophisticated problems, is what I'm trying to say. Okay, again, x plus 1. Fuck. 3x cubed plus x minus 11. 3x cubed divided by x. 3x squared. Okay, then it multiplied to x becomes 3x cubed again. 3x squared times 1 is just 3x squared minus, is that right? That becomes that, that becomes that. Okay. These cancel. Minus 1. Okay. Again. Minus 3x squared divided by x is minus 3x. Minus 3x times x is that. Okay. Minus 3x times 1 is minus 3x. Again, was it right? Was it right? It was right. Okay. These two cancel. This becomes positive 4x. So 5x. 4. No. What? Positive 3x. So 4x. See? If I just rushed it, I would have made that mistake. So 4x minus 1. Okay, and then one last. Just have to get the last term. 4x divided by x. 4. 4 times fucking x, 4x. 4 times 1, 4. 4, yep. Minus 1, yep. Okay. So these cancel, this becomes negative 4, negative 1, negative 5. So our final answer is 3x squared minus 3x plus 4 minus 5 over x plus 1. Three x squared minus 3x plus 4 minus 5 over x plus 1. Yep. Oh my fuck! Are you kidding me? No fucking way. Ah, it's literally my answer though. Fuck. I got greedy and didn't fucking. Three x squared minus 3x is 4. What the fuck is going on? Was it because this wasn't in parentheses? Three x squared minus 3x plus 4. 3x squared minus 3x plus 4. Wait, 15. Oh my god. Minus 11. Wrote the fucking problem wrong. It's okay. We'll just go to the next one. Skip. Next question. It's so fucking hot as well. Mic check, mic check. Oh fuck, sorry. Okay, so if you can hear in the background, I actually turned on my electric fan because it is fucking hot. So bear with me for this video. It probably would have been made more sense to just do the video in the evening, but I have been procrastinating, I guess you could say, from doing math, so I will bear through this. Okay. Write the fucking problem correctly this time. 4x minus 3. 4x squared minus 7x minus 4. X minus 4. Okay. 4x cubed squared. That's right. Cancels. We're left with 2x squared here. Yep. Minus 7x minus 4. 2x. 2x times 8 times 4 is minus 8. 8x. 2x squared. Cancels. Becomes positive. X minus 4. And then becomes 1. 4x squared plus 2x plus 1. 4x squared plus 2x plus 1. Okay. X plus 7. X cubed plus 5x squared minus 9x plus 30. X cubed, x squared, x cubed, 7x squared, minus 2x squared, minus 9x plus 30, minus 2x, minus 2x times x. Yep, that's correct. 14 minus 14x, parenthesis, minus, cancels, becomes positive, positive 5x, 30, x, becomes plus 5x down here, 5 times 7, 35, cancels, becomes negative 5, x squared minus 2x plus 5 minus 5 over x plus 7 minus 5 over x minus 7 plus 7. Shit. X squared minus 2x plus 5 plus minus 5 over x plus 7. Check. Your answer should be in the form p of x plus k where, okay, yep. Again, x squared, we're gonna turn this into the difference of squares, so x squared, x plus 3, x minus 3 becomes x squared, plus 9, so, minus 9, which is the equivalent to just adding plus 2 to this. I mean, this becomes equivalent to that if we do plus 2 with this expression. So, plus 2, x plus 3, cancels, we're left with x minus 3 plus 2 over x plus 3. Two over x plus 3. Okay, this is just long division. X plus 3, 2x cubed minus x squared minus 12, 2x squared, 2x cubed, yep, 2x cubed, 2x squared, plus 6 x squared. Oh, doing all these manual calculations is like stamina. I reckon my brain is like working overtime, but so it means it's good. It's a good thing for like mathematicians and people trying to, I guess, improve their work capacity. Yep. Minus 7x squared. Minus 7x squared. Minus 12. Minus 7x. Yep. Minus 21x. Yep. Plus 21x minus 12. Last one. Plus. It's gonna be some big ass number. I feel like it's wrong. Fuck. I'm just gonna redo it just to be safe. X plus 3, 2x cubed minus x squared minus 12. Oh fuck, did I even say the math continued? Shit. Polynomial division business. Let's say 35. I talk a lot of shit. Let's see, I'm solving the right question, so, yep. 2x squared plus 6x squared minus minus 7x squared minus 12. And here, minus 7x. Yep. Minus 7x times that is 21 minus 21x. Fuck, okay. These two. Oh, wait. Positive 21x minus 12. X divided by that is 21. 21 times 3 is 63. So 63, 21x, 21, then minus, minus 75, I guess, minus 75. I feel like this is not the answer, but I've arrived at it twice, so fuck. $25, $21. Minus 75 over x plus 3. Let's see. 2x squared minus 7x plus 21. Yep. Plus minus 79 x plus 3. What? X squared plus 5x plus 5 x plus 3 x squared 3x parenthesis minus. And guys, like when you do math like this, I just realized, like, you know, it's okay to be in the zone. It's okay to be a bit heated. That's just part of the game, you know. You do the reps. How many reps of this polynomial division bullshit have I done in the past, like, 24 hours? A lot of reps. You know, I wasted, like, I didn't waste. That's the point I'm trying to make. I did like an hour and a half worth of polynomial division yesterday because I was not getting the freaking. I kept making dumb mistakes, and I just wanted to like prove myself that, oh, I can actually do this and not make the mistakes. And now I've kind of, hopefully I don't jinx it for the last two questions, but you realize things like this measure twice, cut once kind of like deal, right? So every time I do a manual, it's like my brain has evolved so that every time I draw this line, every time I do this, it's a bit faster, it's a bit quicker. It knows subconsciously what to check. So I think that's one of the reasons, as well as like math is like fucking amazing. Because of that, it's like magic. You're literally evolving as a species, as an organism. Anyways, x, boom, boom, boom. That looks right. Drop, 2x plus 5. Oh, I could have actually probably. I'm gonna go back and I'll do complete the square, because again, if you can do complete the square, it's superior because there's less steps. Even if it's more sophisticated, it's like there's less steps, and my weakness is human error. So, and I think everyone has a weakness of human error, unless you're a fucking savant and you just never make mistakes, no matter how simple or sophisticated your calculations are. Anyways, you're gonna do x plus 3 and this is uppercase B, so 5 minus 3 is 2. So we're gonna do x plus 2, x plus 2, and we'll know that uppercase C is 3 times 2, like that. No, what am I doing? If we expand this, we get x squared plus 5x plus 6 is what I'm trying to say. So we just have to sorry, give me a sec. Yeah. X squared plus 5x plus 6 minus 6 plus 5. Is that right? Minus 1. Yep, so we just have to put minus 1 on the outside, because we made this imaginary equation and we just kind of borrowed, and then we ended up with minus 1 on the outside. X plus 3. And then plus x plus 3, x plus 2, x plus 3 cancels. So x plus 2 plus minus 1 over x plus 3. X plus 2 plus minus 1, 1 over minus 1 over x plus 3. Let me just double check that. Yeah, I'm pretty confident that's the answer. Aha, a fucking careless mistake. X plus 2. Yep. Okay, then we have to long division this. X plus 3. Oh, fuck. What am I doing? X plus 3 over here. 2x cubed minus x squared minus 25x minus 12. 2x squared. 2x cubed. Plus 6x squared minus, oops, minus cancels, minus 7x squared. Let's see, I just wrote the thing right. So 3 minus symbols, 25, 12, x, 2, x plus 3. Yep, okay. This is right. Minus 7x squared is 25x minus 12. This is minus 7 minus 7x squared, 7x minus 7x, 3 minus 21x, 21x, parenthesis, minus, cancels out, becomes positive, we'll end up with minus 4x minus 12, minus 4x minus 12, minus 4, we end up with minus 4x, and minus 12, and then we do that, and then it becomes 0. So it's a perfect, there's no remainder, that's what I'm trying to say. Is that a 2 or a 3? Fuck, I'm about to get destroyed. It must be a 2. Minus 7x plus 4, minus 7x plus 4, not minus 4. And again, I should have been checking. I should have been checking while I did all of this. If I fuck up the last question, it's because I wasn't checking hard enough. Not like I shouldn't be checking now. I should have been checking while making these calculations, right? 2x squared minus 7x minus 4. Okay. Fuck yes. This is the point I'm trying to make, guys. Like, especially writing on this piece of shit like mouse. If I make a mistake, I have to freaking click the eraser and then, you know, try and select this stuff that I need to rewrite, and so it's very unforgiving. So even for me, from an efficiency standpoint, to like write when it comes to writing stuff, I need to make sure what I'm writing actually matters, that it makes sense. I don't want to go back and forth and like, fix careless mistakes because I just didn't care enough while I was doing those error calculations. So yeah. Woohoo! Fuck yeah. What time is it actually? It's 1:05. It's only 12 p.m. I don't really have like a proper training today, but I might take a break anyways, cause yeah, I'm still sick. That's not cope. I actually am. Um. Hmm. Or do I want to just gun it? Gun it to the end. Let's see how much do we have left. Oh, it's so close though. So close though. Expand using partial fractions. Oh, owie. Summation notation. Okay, so a bit of, Ariston lore. Summation notation is, I see it everywhere with statistical models, AI, machine learning, but I cannot fucking interpret this for the life of me. And this is a simple one. I think it's like J starts at 1, it keeps going until it's 2, and then you just sum every value of J with one another. So it's like J1, J2, and it stops there. And yeah, you feel me. Anyways, partial fraction expansion. Let's go back there anyways, and go back here. Okay, I will take a break. Just keep it fresh. Take advantage of the fact that I have a lot of free time today. And then we'll come back at it, and we will finish Unit 6 today and probably do more. Try and hit 3 hours today. I'm still gonna do the Let's Learn free code camp later, but that, because it's more cookie cutter. It's just yeah, I'd say math is more intense than like fucking HTML and CSS. So, but it is both are really fun. I enjoy both a lot. Like one is a good break from the other. Anyways, I will pause the video and come back in like 2 seconds in your time. And we're back. Whoops. Whoops.
Let's see if we can learn a thing or two
Whoa.
about partial fraction
Oh,
expansion, or sometimes it's called partial fraction decomposition. Partial
This
fraction
video is so old
expansion.
that he's doing it in MS Paint.
The
and
whole
video
idea is
only
to
goes
take
up to 360p,
rational functions,
and it's
rational
super
function is just
loud and
a
crackly.
function or expression where
Let's just
the numerator has a lower degree. First step we want to do to simplify this,
you'll remove
get
x
it
squared
to the point where the numerator has a lower degree than the denominator.
Actually, I don't know.
It's to do a little bit of algebraic division, and I've done a video on this, but it never hurts to get a review here. So to do that, we divide the denominator into the numerator to figure out 40 minus 37. Subtract this, and then minus plus next minus 3x. But this convert improper regular. It's important to keep. This might seem like some type of magic thing I just did, but this is no different than what you did in the 4th or 5th grade, where you learned how to convert improper regular fractions into mixed numbers. 2 is you divide 13. Would be, well, you did it in elementary school. The same thing we did here.
Number,
the denominator went into the numerator one time. This in degree. So we're ready. Let's see color over. We're going to expand it into 2 simpler expressions where each of these are the denominator. Name is over x plus over for a. Do that, sir. And plus b over x minus 8 is equal to. Well, let's get the common denominator. And then the a term, we would a over x plus 5x cancel to get the common denominator.
Okay, let's see what he did here. X is 3, x is 5, x minus 8, 1, x plus 5 plus b, x minus 8. Why?
We would realize that, look, this term is the exact same thing as this term if you just cancel.
Yes. Okay.
So the x minus 8 out.
Yeah, okay, I see what
and
you
this
mean.
term is the denominator a. top b later. When you add
I want
this
to try some
together, you have to
questions.
times x plus 5. Now, there's
Seems
two
simple.
ways to, in A and B from
I do x plus 3 and then this.
this tends, if you what I'm is equal to a times minus 5 minus 8. Let me just write it out. Minus 5 minus 8 plus b times minus 5 plus 5 equal to 0. I might rid of 8. A times 0. A times 0 plus b times, what's 5? 8 plus 5 is plus b times 13. B looks a bit like a 13. And then you get 11
Sorry.
is equal to 13b. Divide both sides by third compose. And what's right, in algebra you probably won't, but this is actually a really useful technique later on when you get to calculus and actually differential equations, because a lot of times it's much easier, and I'll throw out a word here that you don't understand, to take the integral or the antiderivative of something like this than something like this. And later when you do inverse Laplace transforms and differential equations, it's much easier to take an inverse Laplace transform of something like this than something like that. So anyway, hopefully I've given you another toolkit in your, or another tool in your toolkit, and I'll probably do a couple more videos because we haven't exhausted all of the examples that we could show for partial fraction decomposition.
But that's indeterminate. I don't know. Unlike system of equations where they're only why can't we assume that? Okay, let's keep watching. We can always
Let's
go
see
back.
if we can tackle a more complicated partial fraction decomposition problem. I have 10x squared plus 12x plus 20 minus 8. The first thing to do with any of these rational expressions that you want to from expression, the degree of the hopefully you should always think about what doesn't degree use. We have to figure out the factors of the denominator. Make sure that
okay, let's listen.
X squared plus 12x plus 20, all of that over x to the third minus 8. The first thing to do with any of these rational expressions that you want to, I guess, decompose is to just make sure that the numerator is of a lower degree than the denominator. And if it's not, then you just do the algebraic long division like we did in the first video. But here you can do from expression, the highest degree term here is a second degree term, here it's a third degree term, so we're cool. This is a lower degree than that one. If it was the same or higher, we would do a little long division. The next thing to do, if we're going to decompose this into its components, we have to figure out the factors of the denominator right here, so that we can, use those factors as the denominators in each of the components. And a third degree polynomial is much, much, much harder to factor than a second degree polynomial normally. But in this case, there's something should hopefully pop out at you. If it doesn't immediately, hopefully what I'm about to say will make it pop out at you in the future. Is you should always think about what number, when you substitute into a polynomial, will make it equal to 0. And in this case, you say, well, what to the third power minus 8 equals 0? And hopefully 2 pops out at you. And this is something you can only do really through inspection or through experience. And you immediately see 2 to the third minus 8 is 0. So 2 is a 0 of this. So 2 is 0, or 2 makes this expression 0. And that tells us that x minus 2 is a factor. So we can rewrite this right here as 10x squared plus 12x plus 20 over x minus 2 times something, 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 something. We don't know what that something is yet. And I just want to hit the point home of why this is true, or what the intuition by it is true. If 2 makes this 0, 2 should also make the factored expression 0. And we know that 2 would make this factored expression 0, because when you put a 2 right here, this factor becomes 0, so it'll make the...
I want to explain in my own words why that makes sense. Because the... Jeez. Okay, so... I think that when you solve... It's either the y-intercepts or the x-intercepts. I don't know. No, I need to try harder. Okay. is the x-coordinate, x-intercept, the solution. Represent the values of x that make the function equal to 0. Okay, so basically, yep, these are the parts of the function that these are the values of x that make y equal to 0. Okay, these are the solutions. Why are they the solutions? I'm not sure. But that's why we
The
know
whole
that.
thing 0. And so that's why, that's the intuition where if you substitute a number here and it makes this 0, you do x minus that number here. And we know that that will be a factor of the thing. Well, anyway, the next step, if we really want to decompose this rational expression, is to figure out what this part of it is. And the way to do that is with algebraic long division. We essentially just divide x minus 2 into x to the third minus 8 to get this. So let's do that. So we
Okay.
get
X minus 2 is the
minus 2
divisor.
goes into x to the third.
Minus 8.
And actually, what I'm going to do is I'm going to write, I leave space constant there. We'll go squared. Now we want to subtract squared. So x times x
I don't
squared.
like that he does this.
2x times minus 2
I
is
feel it's very
minus
unnecessary.
4x. Subtract that from that. 4 times 8 leaves third minus 8. So now we can write x minus 2 is equal. I won't be. Let me write it down. Let me write it down here. What was it? It was 10. Let me switch. We can write our original problem like here. What was it? X plus minus 2 just to factor out that x to the third minus 8. But now we can actually do some partial fraction expansion or partial fraction decomposition. So this is going to be equal to, and this is the interesting point. This is where we diverge or advance a little bit from what we did in the first video. This is going to be equal to a constant over this denominator, over x minus 2, plus, and this is a little different than what you're going to see, what you saw in the last video, plus an x term, some coefficient times an x term, plus c, so bx plus c over this.
A bx plus c
squared
is constant,
plus
I guess.
2x plus 4. And you might say, Sal, how did you know to do that?
Before he explains, I just want to say I don't have any intuition as to why this works, but I guess he's about to explain it. So, some people get too frustrated about like not knowing why something works. I'm not saying that's a bad thing all the time, but sometimes you learn that something does work, and then you learn why it does later on. A lot of things in history have been discovered like that. So it's the same with learning.
Well, what you do is you look at the degree of the denominator. This is a first degree denominator, and you say, okay, the degree of the numerator in this part of the fraction, I guess you could call it, is going to be 1 less than that. So this is first degree, so this is going to be a 0 degree or a constant term. Here the degree is 2, right? The degree is 2, so the degree of its numerator is going to be 1. And since its degree is 1, it could still have a constant term, which is a 0 degree term. So you get bx plus c. And you know, maybe it does end up just being a constant, in which case we can solve for b, and it'll just be 0. And actually, there's another thing you might be asking. Is like, hey, why don't we factor this further? And you can try, but if you look at it by inspection, you could kind of in your head do the quadratic formula, and you'll see that you'll only get imaginary roots here. So this actually isn't this isn't factorable in the reals anymore. There are no more real zeros to this. So we have factored this as much as we can. So the key now to complete our partial fraction expansion is to just solve for the a, b's, and c's, and we'll do it exactly the same way we did in the last video. So what we want to do is essentially add these two things. So if we add, let me write this on the left-hand side. So 10x squared plus 12x plus 20 over x minus 2 times
Hold on.
x squared plus 2x denominator plus 4. Just multiply the two things. And then that'll be, if when we add the common denominator, then it's a times this, x squared plus 2x plus 4 plus bx plus c, bx plus c times this, times x minus 2. Well, then
Okay, so really, we just combine them by giving them the same denominator, numerator. Yeah, denominator. So you would multiply this one by the denominator of this, like to the numerator and denominator, and then vice versa for the other
denominators are
side.
the same, so the numerators have to equal each other. So we have plus a plus minus 2 that I do in the last video. It would assist all b or speaking 4, right? Then we're left with unknowns very minus bx plus c. All of that times x minus 2. This might look like a hairy problem, and if you do it kind of the slow way that I do in the last video, it would take you forever. It would be 3 equations and 3 unknowns, very, very hairy. But what we can do is a system, oh, pretty much the same way we did it the first one. Let's pick x values that simplify this and allow us to solve for one of these a, b, or c's at a time. And the immediate thing is, well, what x value can I substitute that will cancel out at least 2 of the variables, 2 of the a, b, or c? And
0 probably. Yeah.
if I put x is equal to 2, then this thing becomes 0, which will make this whole expression 0, and I'll just be left with
Oh. Yep.
an a, and the x's, which I'll know is 2, because I'm picking x to be equal to. So let's do that. So if x is equal to 2, x is equal to 2, 4, there it is, 4 plus 4 plus 4. And this is what? 10 times 4 is 40, plus 44, that's 84. Will make the b disappear, or the c. Well, we can make the b disappear if we make x is equal to 0 plus 0 plus 4.
Yeah, this is such a fucked up
7
problem.
times 4
to solve manually.
plus bx plus c.
I thought
the
the pain
bx
was
just
over.
disappears.
It is not.
b minus 2, c times
Holy
minus
shit.
2. 8 minus 2c. Subtract 28 from both sides. Minus 8 is equal to minus 2c. c is equal to 4. It teaches for e is equal to that. You can do p and 4.
Oh my god,
and a
what's
is
the
equal to
fucking
7.
exercise
So the
gonna be
partial
like?
fraction.
Okay. Using partial fractions. Okay, so the top is x plus 5, x minus 5, because it's a difference of squares. Then from here, is there anything we can do? X squared plus 5x, say plus 5 minus 5, plus 5 minus 5 would be 0 actually. Fuck. I don't know, we have to skip and see how he does it. First, let's factor the denominator. Okay. Minus 3 plus 8. This. And be our polynomials. Fuck. No, I have to watch the videos again. There's no chance that I'm gonna get it.
Let's see if we can learn a thing or two about partial fraction expansion, or sometimes
I wish the audio quality wasn't such dog shit.
it's called partial
Am I even
fraction
recording?
decomposition.
Yes.
Partial fraction expansion. The whole idea is to take rational functions, and a rational function is just a function or expression
Fuck, wait.
by another, and to essentially expand them or decompose them into simpler parts.
Right.
And the first thing you got to do before you can even start the actual partial fraction expansion process is to make sure that the numerator has a lower degree than the denominator. And the situation, the problem that I've drawn right here, or I've written right here, that's not the case. The numerator has the same degree as the denominator. Right here, or I've written than the expansion process is to make sure that the numerator has a lower degree than the denominator. And the situation, the problem that I've drawn right here, or I've written right here, that's not the case. The numerator has the same degree as the denominator. So the first step we want to do to simplify this and to get it to the point where the numerator has a lower degree than the denominator is to do a little bit of algebraic division. And I've done a video on this, but it never hurts to get a review here. So to do that, we divide the denominator into the numerator to figure out the remainder. Just look at this plus 3 minus 40. It's important to keep, this might seem like some type of magic thing I just did, but this is no different for 40. That's plus 3. So this expression up here can be rewritten as, let me scroll down a little bit, over x squared minus 3x minus 40.
Hold on. X plus 3 over x squared minus 3x minus 40. Okay. X plus 3. Alright, okay, so that's where we had to stop. Then x plus 3 is all that's left.
It's important to keep, this might seem like some type of magic thing I just did, but this is no different. Proper regular fraction. You see it is using the 13 of 1. 2 doesn't go into 1, so that's just the remainder over 6.5 here. It's 3 over, so it's 1 plus numerator. In this rational expression, the numerator does have a lower degree than the denominator, right? The highest degree here is 1. The highest and let's see, minus, so it has to be x. 40. 5 times negative 8 is minus 40. Plus 5 minus 8 is minus 3. So we're all set. Now I'll just focus on this part right now. This have to plus 40. Let's see. They have to be different signs.
Where the fuck did 1 come from again?
Half. And that's exact school denominator. That seemed like some type of denominator.
One is the
like we did
remainder.
Over here. 2 goes into 13. You say 2 goes into 13 6 times.
I see.
Did it in else exact than the original making where the lower term. Multiply them, you get minus 40 times x minus 8.
They're kind of like
5 times 8 is minus 40. 5 times negative 8 is minus 40. Plus 5 minus 8 is minus 3. So we're all set.
Wait a minute. He rewrote the bottom expression as the binomial factors. Okay.
Now I'll just focus on this part right now. We can just remember that 1 is sitting out there out front. Expand, and I just fraction 5. But I can expand this or decompose this into 2 fractions, where the first fraction is just some number a over the first factor over x plus 5 plus some number b over the second factor over x minus 8. That's my claim. And if I can solve for a and b in a way that it actually does add up to this, then I'm done. And I will have fully decomposed this fraction, I guess is the way. I don't know if even that's the correct terminology. So let's try to do that. So if I were to add these 2 terms, what do I get? Well, when you add anything, you find the common denominator. And the common denominator, the easiest common denominator, is to multiply the 2 denominators. So let me write this here. So a over x plus 5 plus b over x minus 8 is equal to, well, let's get the common denominator. It's equal to x plus 5 times x minus 8. And then the a term, we would, a over x plus 5 is the same thing as a, right?
Yep.
X plus 5 times x minus 8. And it would be b times x minus 8. And it would be b times, this term is the exact same thing as this term if you just cancel the x minus 8 out. And this term is the exact same thing as this term if you just cancel the x plus 5s out. Let's write the left side. I don't x minus 8 a equal to,
what the fuck did you draw?
I want to write this over here.
I think fuck he does not do
x
that
plus
anymore.
3 over x plus 5 times x minus 8 is equal to the sum of these two things on top, a times x minus 8 plus b times x plus 5, all of that over their common denominator.
Yep.
X plus 5 times x minus 8. So the
Wait.
denominators are the same.
Let me just double check. He wrote that. He wrote that.
Minus 8.
Yes. X is 3. That was that one. Yep.
This. So if we want to solve for a and b, let's just set that equality. We can ignore the denominators. So we have to get. So the denominators are the same. So we know that this, when you add this together, you have to get this. So if we want to solve for a and b, let's just set that equality. We can ignore the denominators. So we can say that x plus 3 is equal to a times x minus.
Oh my
One is the way that
God.
I was
Is
actually
he gonna
ways
write everything
b.
again? I don't know. Oh, we right. Okay, we removed the denominator completely because it's the same.
Times x plus 5 forward. One is the way that I was actually taught, in the 7th or 8th grade, which tends to take a little longer. Then there's a fast way to do it, and it never hurts to do the fast way first. If you want to solve for a, let's pick an x that'll make this term disappear. So what x would make this term disappear?
Minus 5.
If I say x is minus 5, then this becomes 0,
yes.
and then the b
so
disappears.
We isolate.
So if x is, if we say x is minus 5, is equal to minus 8 plus b 5 plus 13, 0 times b is 0, and then you divide both sides by minus 13, you get a, and now it's equal to a times 0. If is equal to a times 0, a times 5 is plus b times 13. The third b looks a bit like a 13. And then you get 11 is equal to 13b. Divide both sides by the equation, and we could say, wow, to be R1 here. Now realize some transforms and differential equations.
So things we gotta remember: numerator has to be a lower degree. First thing we did was we divided it. Yeah, we divided it and then re-expressed this. What else did we? 1 plus, and then we broke it down into its binomial factors. And then we did that magic with the where is it? A and B. Yeah. A over binomial 1, b over binomial 2, then plus. What is this? X plus 3. Where did x plus 3 come from? Maybe there was no x plus 3. Oh, I see. Okay. So
Is the term x plus is e?
Yeah. Okay. So we did A and B go on top. These stay at the bottom, and then we cancel it out, and then we kept solving.
Yeah, cool.
Okay.
Do make the x. I'm just my 6 minus 13.
Keep going.
3.
Okay.
We
set something to try and solve for. How many steps is that? Couple steps.
Plus multiply.
Let me think.
And now you want to subtract this, and then minus, that's a plus.
Yeah, okay. So let me run it through my head again. Numerator has to be lower than denominator. Some basic remainder, some basic, algebra. And then from here, if something is over 2 binomial factors, then it will be equal to a over binomial factor 1, and then b plus b over binomial factor 2, and then we can actually add those things together, and the resulting sum will be, the resulting right hand side will have the same denominators as the left hand side, then we can cancel it out. Okay, yep, over here he does that, so removes all of this. We're left with x plus 3 equals ax minus 8 plus bx plus 5. From there, we solve for a and b, and then
5 times
how do we close the deal?
5 by making x is equal to
From
a
there,
to 11.
we learn a and b.
So so this, our very original thing we wrote up 13. I'll bring the 13 here. If you want 2 over 13 over x plus 5. And once again, you could bring 7. You want 2 over is 2 over 13. I'll just write it like this for now. 2 over 13 over x plus 5. You could bring the 13 down here if you want to write it so you don't have a fraction over a fraction. Plus 11 over 13, 8. You could say, oh, you only have one expression here. Now I have 3. But I've reduced the degree of both the numerator. Right, in calculus and actually the integral or the antiderivative of something like this than something like this. And later when you do inverse Laplace transforms, then something like that. So
Okay.
fraction d. Let's see if we can tackle a more complicated partial fraction decomposition problem. I have
Do not give up, Ariston.
these
10x
rational
squared plus
expressions.
12x plus 20, x cubed minus 8. Okay, so the top. The numerator is already lower than the denominator, and the denominator has a third degree, I guess.
You want to, I guess, decompose is to just make sure that the numerator is of a lower degree than the denominator. And if it's not, then you just do the algebraic long division like we did in the first video. But here you can do from expression, the highest degree term here is a second degree term, here's a third degree term, so we're cool. This is a lower degree than that one. If it was the same or higher, we would do a little long division. The next thing to do, if we're going to decompose this into its components, we have to figure out the factors of the denominator right here, so that we can, use those factors as the denominators in each of the components. And a third degree polynomial is much, much, much harder to factor than a second degree polynomial normally. But in this case, there's something should hopefully pop out at you. If it doesn't immediately, hopefully what I'm about to say will make it pop out at you in the future. You should always think about what number, when you substitute into a polynomial, will make it equal to 0. And in this case, you say, well, what to the third power minus 8 equals 0? And hopefully 2 pops out at you. And this is something you can only do really through inspection or through experience. And you immediately see 2 to the third minus 8 is 0. So 2 is a 0 of this. So 2.
Goddamn, like, I watched the full CS50, and I just realized, like, listening is a skill. Taking information in is a skill. Being present and being able to absorb information effectively through your ear holes and eye holes, like, it's pretty important.
2 is 0.
A lot of people don't listen up.
Or 2 makes this expression 0. And that tells us that x minus 2
is a 0. Okay.
is a factor. So we can rewrite this right here as 10 x.
Fuck. Sorry for the ear rape, but that makes a lot of sense. Okay, so
Or through
anything, if this is a function, right? If the denominator is 0, then it's a 0. So that also fits in with the idea of like an x-intercept, and we know that the x-intercepts are essentially the opposite. No, they are the solutions to a quadratic. An x-intercept is like where the value of y is equal to 0, essentially touching the x-axis, right? So we're able to deduce that
experience. Okay. And you immediately see 2 to the third minus 8 is 0. So 2 is a 0.
No, 2 is a 0. Okay, so 2 it's x minus 2.
Is
that's one of
0.
The solutions.
Or 2 makes this expression 0. And that tells us that x minus 2 is a factor.
Yep, okay.
So we can rewrite this right here as 10x squared plus 12x plus 20 over x minus 2 times something, 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 something.
Yeah.
We don't know what that something is yet. And I just want to hit the point home with why this is true, or what the intuition by it is true. If 2 makes this 0, 2 should also make the factored expression 0.
Yeah.
And we know that 2 would make this factored expression 0, because when you put a 2 right here, this factor becomes 0, so it'll make the whole thing 0. And so that's why, that's the intuition where if you substitute a number here and it makes this 0, you do x minus that number is minus 2, x minus 2. Figure out what this part of it is.
Sometimes I have a tendency to skip ahead, but he might say something really important.
Way to do that of the thing. Well, anyway, the next step, if we really want to decompose this rational expression, is to figure out what this part of it is. And the way to do that is with algebraic long division. We essentially just divide x minus 2 into x to the third minus 8 to get this. So let's do that. So you get x minus 2 goes into x to the third. And actually, what I'm going to do is I'm going to write, I leave space for the second degree term, which is 0, the first degree term, and then minus 8 is the constant term, so minus 8. I like to put all my degree terms into what goes into times x minus 2. X squared times x is x squared. So I'm left with
just doing long division
2x
here.
squared. You just look at the highest degree terms.
Skip
X goes
slowly.
into 2x. 2x times x is minus 4 times x minus further. And the other factor is minus 8. And there's no remainder. And this is further confirmation that x minus 2 definitely was a x plus x. So, and now we want to subtract that.
Okay, so we just divided this by that. This is the dividend divisor. Okay.
From that.
Okay, very simple. You know, the factors should form this, the original expression. So, okay,
so times
very
2
easy.
x minus 2, another color, plus 20. Let me write it down here. What was it? It was 10. Let me switch to another color. It was 10x squared. I have a bad memory. Plus 12x plus 20 over, what was 2x to the third minus 8. But now we can actually do some partial fraction expansion or partial fraction decomposition. So this is going to be equal to, and this is the interesting point. This is where we diverge or advance a little bit from what we did in the first video. This is going to be equal to a constant over this denominator, over x minus 2, plus advance a little bit from what we did in the first, going to be equal to, and this is the interesting point. This is where we diverge or advance a little bit from what we did in the first video. This is going to be equal to a constant over this denominator, over x minus 2, plus, and this is a little different than what you're going to see, what you saw in the last video, plus an x term, some coefficient times an x term, plus c, so bx plus c over this, x squared.
Trying to think why. So bx to c. Last video we had just a and b. Now it's bx to c.
And this is, so all the work we did so far is just to factor out that x to the third minus 8. But now we can actually do some partial fraction expansion or partial fraction advance a little bit from what we did in the first video. This is going to be equal to
partial
a constant
fraction decomposition
over this
partial
denominator, over x minus 2,
This is what we are doing.
plus, and this is a little different than what you're going to see, what you saw in the last video, plus an x term, some coefficient times an x term, plus c, so bx plus c over this, x squared plus 2x plus 4. And you might say, Sal, how did you know to do that? Well, what you do is you look at the degree of the denominator. This is a first degree denominator, and you say, okay, the degree of the numerator in this part of the fraction, I guess you could call it, is going to be 1 less than that. So this is first degree, so this is going to be a 0 degree or a constant term. Here the degree is 2, right?
Okay.
The degree is 2.
Okay.
So the degree of its
So
numerator.
this works for pretty much different degrees, whereas last time it was just a and b. So you look at the numerator and denominator, you compare them. Sorry. No, it's a fucking denominator. You look at the power of you look at the degree of the denominator, and then you assign 1 less of that to the numerator. So this is a degree of 2. This becomes a degree of 1.
This is going
a
to be
degree of 0.
1. And since its degree is 1, it could still have a constant term, which is a 0 degree term. So you get bx plus c. And maybe it does end up just being a constant, in which case we can solve for b, and it'll just be 0. And actually, there's another thing you might be asking is like, hey, why don't we factor this further? And you can try, but if you look at it by inspection, you could kind of in your head do the quadratic formula, and you'll see that you'll only get imaginary roots here. So this actually is close to this. So we have factored this in, is to just solve for the a, b's, and c's, and we'll do it exactly the same way we did in the last
B's,
video.
and C's, okay.
So let me write 12 times x
so we're gonna
squared plus
multiply, like cross multiply, so that we can get rid of all of this crap at the bottom.
2 squared 2 equals all of that.
Yep.
Do it
Then from here,
kind of the
I believe Sal is gonna choose a value for x that will kind of isolate everything. So he would, I know this because I watched the video earlier, which is fine. He would set x to +2, and it will force this to become 0, and then these will also become 0 because 0 times anything is 0, right? And then from here it will be like 4, 4, 4, so like 8, 8, 12, and then he does a bunch of stuff there, and then he solves for A, B, and
this
C one by one.
Okay. Plus 40 is, well, if we add just times 0, we get 20. If I can 7 plus c is 4. So now math is 10. E times 1 minus equal c. You can equal 45. And your original c was equal to 4. C is equal to 4. And a is equal to 7. So the partial fraction decomposition of this, we're now done, is 7 over x minus 2 plus 3x plus 4 over x squared plus 2x plus 4. Well, that was a pretty tiring problem, and as you can see, the partial fraction decomposition becomes a lot more complicated when you have higher degree denominators, but hopefully you found that a little bit useful.
Recent. The beeping sound is driving me crazy. Okay, let's get ready to rumble. Ah, fuck, I feel like you heard that in the video. Collarbone popped. Okay, where are we? Okay, minus 10x minus 5 x squared plus x 42. Okay, let's think about this. Okay, let's look at 42 and its factors. 1, 21 and 2, 3, 3? Yes, 3, 14 and 3, 38, yep. 4, not 4. 5, not 5. 6 and 7. Yeah, okay. 7 and minus 6. So the bottom is actually, so it actually looks like this. X plus 7, x minus 6. Is that right? Yeah. Now we do this. X plus 7, x minus 6, a, b plus, let's just expand it to the right because it doesn't have much space at the bottom. B, a, x minus 6, this will be b, x plus 7, then it'd be x plus 7, x minus 6, x plus 7, x minus 6, then from here we would just cancel these out. Right, now I'm just gonna save the writing, and I want you guys to know that we're not looking at this. Okay, I could probably even just cross it out, to be honest, so that we're like here and here. Sorry if it's a weird viewing experience. I'll just rewrite everything actually. Minus 10x minus 5 equals a x minus 6 plus b x plus 7. Oh, actually, this is gonna be our partial fraction decomposition, so we need to keep that. It's actually we'll go back to it after we solve for b and a and b. So from here, we can set a value of x to try and make one of these a 0, so we can isolate the other case. So let's set x to positive 6. So we end up with 10. Negative 10 times 6 is negative 60. Minus 5, that's minus 65. And then 6 minus 6 is 0. A times is 0. So we're just solving for b now. B, x is minus positive 6. Okay. 6 plus 7. 6 plus 7 is 13. So b 13. And then we just, or 13b, then we just transpose it like this. So b equals negative 65 over 13. Then we do the other one. So, fuck, plus 6, minus 7. Minus 7 times minus 10 is 70. Minus 5, that's 65. Equals, yep, okay, left hand side done. We're doing minus 7, so this times this cancels out. Then minus 7, minus 6, minus 13. So a is negative 13a, or 65 over negative equals a, like that. And they're equal? The chances that they became equal is pretty low, I think. Okay. Fuck. I don't know how I'd even write it. Okay. So they're both equal to the same thing. 65 over 13. Five over 13 plus x plus 7 plus 65 over 13 over x minus 6. Why are they not on the same level? 65 over 13 over is that right? X minus x, x plus 7, 65 over 13. Okay, the x minus a b is the second one. Okay, minus there, minus there. Show a step. Takes fucking ages. How the fuck did I get... Oh, you gotta be fucking kidding me. I fuck. -5. -5. No! I didn't realize 65 was divisible by 13. Bastards. Okay. We'll keep going. -8x plus 24. Okay, let's think about this. -6 minus 2. Okay. X minus 6. X minus 2. Minus 8x plus 24 equals, okay, x minus 6 plus x minus 2 a b equals ax minus 2. Sometimes watching another person doing math is actually like low-key harder than just doing the math myself, you know what I mean? Like, it's so much to keep track of someone else's work. Then I'll just equal goob. Okay, let's just call that goob. Goob. And then over here it's minus 8x plus 24 goob. And then we cancel out the goobs. We end up with this. Ax minus 2 fucking b x minus 6. Okay, now we solve. I will write a box so we can solve. Okay, so the values we want to substitute for x is +2 and +7. Okay, so I want to solve this here. 2 times -8, 16, plus 24, that is 40. 40 equals... this is going to be 0, and then 2 minus 6 minus 4, minus 4b, minus 4b, and then there you go. So b equals -10. I need to put more care into my calculations. Hold up. 2, wait, minus 8x. 2 times minus 8x is minus 16 plus 24. That's 8. 8. So I was actually wrong. And then that's going to be 0. This is going to be 2 minus 6 minus 4, b minus 4, minus 4b, and then just transpose. B equals -2. Yeah, now 7. Minus 8 times 7, 56. Yeah, minus 56 plus 24, minus 56 plus 24 is... Oh, that's a weird number. Minus 56. Minus 56 plus 24 minus 32 equals... Wait, why am I doing 7? It's supposed to be... Huh. Oh shit. Uh, 6 over here. Minus 8 times 6 is minus 48 plus 24. 24 equals 6 minus 2, 4, 4a, 4a, a equals 24 divided by 4, 4 equals 6. Okay, now we go back here, and then this is equal to 6 and negative 2. Plus minus 2 over minus 2 over x minus 2. Let's see, 6x minus 2, x minus 2. Oh, fuck. There's so much fucking manual calculation aids. Christ. Minus 6. Minus 6, x minus 6. Minus 6. Minus 6. Such bad design. A is equal to minus 6. Minus 4. Minus 4a. 6. 6 times minus 8. 48 plus 24. 24. Ah, fuck. Ah, fuck me. Okay, I think it's time to call it a video. It's only short. It's only 2 hours, but it's fine. I'm just so drained from all the manual calculations, and I'm still recovering from being sick. So yeah, thanks for watching, and sorry about the quality of the past couple of videos, but yeah, I will record Let's Learn Free Code Camp episode 3 later. And yeah, thank you for watching.